Welcome to another Win with Math video. Today's video, how to perform partial fraction decomposition with nonlinear factors. Take this example, 5x squared plus 10x plus 5 all over x minus 2 times x squared plus 3x plus 5. In the denominator, we have two factors, so we're going to have two different fractions. One fraction with the denominator of x minus 2, which is the linear factor. Here, the numerator we don't know, so we'll call it a. Whereas the other fraction is going to have the denominator of x squared plus 3x plus 5, the quadratic factor. You're probably going to think the numerator is going to be just b, because if you're looking at the linear factor, but then for the one with the quadratic factor, it's actually going to be a little different. The numerator is actually going to be bx plus c. So why is that? The numerator is going to be 1 degree less than the denominator. So if the denominator is quadratic, or x to the power 2, then the numerator is going to be a linear, or x to the power 1. And then if you go back to the linear factor, a over x minus 2, the denominator is a linear factor, which is x to the power 1. So if we go 1 degree less, the numerator is going to be x to the power 0, which is a constant. All right, to save us some trouble, let's put a parentheses around the bx plus c and the 5x squared plus 10x plus 5. All right, let's get rid of all the denominator. Let's multiply both sides by the original denominator, x minus 2 times x squared plus 3x plus 5. And let's see what cancel. On the left side of the equal sign, there's x minus 2, and there's an x squared plus 3x plus 5 in both the numerator and denominator, so those cancel out, leaving 5x squared plus 10x plus 5. On the right side of the equal sign, the a over x minus 2, the x minus 2 is both in the numerator and denominator, so they'll cancel, leaving us a times x squared plus 3x plus 5. For bx plus c over x squared plus 3x plus 5, you'll notice the quadratic factor, x squared plus 3x plus 5, will cancel in both the numerator and denominator, leaving bx plus c times x minus 2. Remember the parentheses we put earlier around the bx plus c? This is where it's going to come in. Because if you don't put the parentheses and simplify, it looks like bx plus cx minus 2c, where it should be like something like bx squared. Okay? All right, now we just need to solve for a, b, and c. So we can take a look at this linear factor, x minus 2, and let's let x equals 2. We'll substitute into our equation, and then we'll simplify. So what we'll get is 20 plus 20 plus 5 is equal to a times 4 plus 6 plus 5 plus, well, 2 minus 2 is 0, so plus 0. So hence we eliminate both the b and the c term. All right, let's simplify some more. 45 equals 15a. Divide both sides by 15 to get a equals 3. So we've solved successfully for a. Now we just need b and c. But then if we look at this, we have x minus 2 factors, and there's no other x value that we can choose that will get rid of both, like a and b or a and c. But we notice there's a bx. So let's just choose a nice x value that will make this nice, which will be, let's let x equals 0. We'll substitute in. So substitute in, we get this, simplify it, and we get 5 equals a times 5 plus 0 plus c, the whole thing times negative 2. Simplify this, we get 5 equals 5a minus 2c. Since we solved for a earlier, which was 3, we'll substitute in. 5 times 3 is 15, and then we'll subtract 15 both sides to get negative 10 equals negative 2c. And then we'll divide both sides by negative 2 to get c to be 5. So we successfully solved for c. We have a and c now, we just need b. Since we ran out of space, let's move on to the next page. So in the previous page, we solved for a, which was 3, c was 5, and then we have this 5x squared plus 10x plus 5 equals to this. This is here for convenience, so we don't have to scroll back and forth. Now, we need to solve for b. So let's pick a different x value. We already chose x equals 2 and x equals 0, so let's choose another x value that will be simple to use, such as x equals to 1. We'll substitute this into our equation, and then we'll simplify. And this is what we get. 5 plus 10 plus 5 is equal to a times 1 plus 3 plus 5 plus b plus c times negative 1. We'll simplify this, and we get 20 is equal to 3 times 9 plus b plus 5 times negative 1. Simplify some more. 20 equals 27 minus b minus 5, and then we'll solve for b. And we get negative 2 is equal to negative b, or b is 2. So we solve for a, b, and c. Last step to do is to write our partial fraction. So we have this 5x squared plus 10x plus 5 over x minus 2 times x squared plus 3x plus 5, and that's equal to a over x minus 2 plus bx plus c over x squared plus 3x plus 5, where a is 3, and b is 2, and c is 5. And this is our partial fraction decomposition for a fraction with nonlinear factors. So with the example that we saw earlier, we saw a linear factor and quadratic factor. You're probably wondering what happens if you have a cubic factor or a quartic factor. So take this example. Here we're going to have the denominator is going to be 2x minus 3, 5x squared plus 4x plus 6, x cubed plus 4x plus 3, and x to the fourth plus 4x squared plus 5. So for the first fraction, the 2x minus 3, we have a linear factor, x to the power 1. Go 1 degree less, and we have a constant, which we can express as this constant a. For the 5x squared plus 4x plus 6, we have a quadratic factor, x to the power 2. 1 degree less, x to the power 1, which is a linear. We can express this linear as bx plus c. But what about the other two? So the main idea here is when you have any partial fraction, the denominator will have a degree of n, meaning the numerator should have a degree of n minus 1. The numerator is always going to be 1 degree less than the denominator. So for the x cubed plus 4x plus 3, we have a cubic factor, x to the power 3. Go 1 degree less, which is x to the power 2, which is a quadratic. So we have dx squared plus ex plus f. And for x to the fourth plus 4x squared plus 5, we have a quartic factor. Go 1 degree less, and we have x to the power 3, a cubic. So that's going to be expressed as gx cubed plus hx squared plus ix plus j. Note that when you solve for your a, b, c, d, e, f, g, h, i, j, they could be equal to 0, but not all of them equal to 0. So for a constant, well, a is not going to equal to 0. For a linear, b and c, one of them could be equal to 0, but not both. For a quadratic, d, e, f, one or two of them could be zeros, but not all three. And if for a cubic, g, h, i, and j, 1, 2, or 3 of them could be equal to 0, but not all 4. So let's look like a linear. Yeah, so if b is 0, then you just have a constant. The main idea is the numerator is at most 1 degree less than the denominator. Okay? All right. Like, comment, subscribe. Thank you.